Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco DevNet, and today I want to talk to you about Goodbye SNMP, Hello NetConf. This is a lesson that's part of our Network Programmability Basics video course, and we are in the module on Network Device APIs. This is the second lesson in this module, and if you didn't catch the Getting the Yang of It with Standard Data Models lesson, be sure to go back and check that one out as well, because it's very highly related to this content on NetConf. Now, if you want to follow along with me as I go through in this example, I highly encourage it. Go up to github.com/cisco-devnet netprog_basics, and you can download all of the code samples and information for this lesson, as well as all the others in the video course. Now, each lab will include a README that provides the details on how to set up your laptop with all the prerequisites necessary to run these exercises. And in cases like this one where you need access to infrastructure, DevNet Sandbox is ready to go. And the READMEs include information on which sandbox you should reserve to get started. Now in this lesson, we're going to cover these topics. We're going to review the road to model-driven programmability. Where did we come from? How did we get to where we're at when we're dealing with Yang, NetConf, RESTconf, and these other topics? Then we'll dive specifically into NetConf, the transport protocol. We'll look at the components of NetConf. We'll see how we use it in code leveraging Python. And then we'll end with an example of how we can use NetConf to automate our network to retrieve and configure interface information. Let's dive right in. So the road to model-driven programmability is a tough one, but why are we even after that? And frankly, it comes down to this idea, right? The network is no longer isolated. We're not just sitting out there with a bunch of network engineers as the only people interested in either configuring or understanding the health of the network. Whether it's cloud aspects and reasons, web applications looking to get information directly from the network, or teams that want to practice DevOps to do network configuration along with the rest of their infrastructure. We've got use cases for Ansible, REST, new data formats for our language such as JSON and XML. All of these are coming at us as network engineers, which means our traditional mechanisms of configuring the network through CLI just don't keep up with their demands today. Now you may be asking yourself, well, we've got something else other than CLI. What about SNMP? We've had that for a while, right? Well, we've all used SNMP, and I think we can agree that to this quote that's here. It works reasonably well for device monitoring. But frankly, very few people are using SNMP for configuration elements of your information. Now, there could be lots of reasons for it. Lack of writable MIBs, the security concerns that we continue to struggle with from SNMP v1 to v2 and v3, and then some of the advanced features we want in configuration tools today, such as replay and rollback capabilities. And so coming together as an industry of network configuration and engineering professionals, we've come up with new standards for model-driven programmability across the industry. And model-driven programmability looks kind of like this, and it's composed of these elements. We have our device that has a set of features. Those features are exposed in both standard as well as vendor-specific fashion across configuration elements and operational data supported by the devices. And how we model, how we articulate and talk about what that information is, be it configuration or operational, that's where Yang data models fit in based on the Yang standard. Now the Yang data models are exposed to the outside world through different transport protocols of NetConf, RESTconf, and gRPC. Now NetConf was the first one that we had, and that's what we're going to talk about today in this lesson. But we also have RESTconf as the newest kid on the block with a standardized RFC in January of 2017. And then an open source project by Google, gRPC, is a standard mechanism for interfacing with lots of different types of systems, not just networking. Now we're not talking about gRPC in the network programmability video course, but it's another up-and-coming one that's interesting to keep our eyes on that's out there. Now as we look at the model-driven programmability landscapes, I think it's important to divide and understand how these things fit, or how these elements fit into either transport protocol or data models. Now, if we take a look at how network transport goes through in kind of a common abstraction of a TCP/IP network frame, on the transport protocol side, dealing with the headers, the Ethernet, the IP, the TCP, just the raw communication over the network, that's where NetConf, RESTconf, and gRPC fit in. Now, what they provide access to is the data, and that data is modeled using Yang to provide there. And what we want to recognize when working with these is that whether we're leveraging NetConf, RESTconf, or gRPC, all of them are using the same Yang data models that are there, which makes this a very robust and flexible model for dealing with network configuration and operations. Now with that in front of us, let's dive deeper into NetConf as the transport protocol that kind of started the boat with model-driven programmability. Now NetConf was originally standardized in 2006 with RFC 4741, but it was updated in 2011 with 6241. Now what's interesting about NetConf is it doesn't explicitly define the content that we'll be working with or that it will be transporting. All NetConf says is that it will deal with XML-based data, and so the data that's embedded in there. And the Yang data model, the Yang standards, are what kind of fits into that bucket of what NetConf will actually work with. And this means that you could conceivably use NetConf as a protocol with other data models other than Yang data models. And in fact, that's what we had initially once NetConf was standardized, because it was standardized several years before Yang came around. Now, if we look at the protocol stack for NetConf, it's important to see how this was built up and gone through. Now, when we designed NetConf out there, we didn't feel the need to design an entirely new transport protocol, right? We've got lots of good ways to communicate with devices and authenticate and provide back and forth between devices. And so NetConf builds on top of SSH for the TCP/IP method. And that means it gets to inherit everything that SSH offers: encryption, security, authentication. All of the ways that we do all of those things with SSH for CLI communication translate over for NetConf communication. Now above the transport layer, we get into the messages, operation, and content from NetConf. And this is where all of that information is formatted using XML. Now messages determine how do we actually make these communications. We open up a NetConf connection to a device and we want to send different remote procedure calls, or RPCs, asking the device for data or asking the device to take some action. That's all an RPC is as it goes through. Inside of those RPCs, we've got a series of operations that we can ask the device to do, and then it will provide us back in data, whether that's configuration or operational data. We look deeper into each of these layers. Let's start out with SSH. Now, as mentioned, we're built on top of SSH, which means I can go directly into my SSH client, just like I do with CLI, and connect and use NetConf. So up at the top, we see here where we're making an SSH login, providing the username and password, and in this case, the port for NetConf, which does standardize to port 830, though your NetConf agent could work on a different port. Now, once we've logged in successfully, the NetConf server, the agent, will kick back and send us back a hello message that includes all of its capabilities. We'll talk more about the capabilities in just a moment, but for now, just think of capabilities as the data models and the NetConf feature set that device supports. Now, in good fashion, our device said hello to us. We need to then reply back with a hello of our own as we go through on this case. And that's how we initiate a connection using SSH with NetConf. Now, having gone through all of this, I want to then say, don't NetConf like this. Using a native SSH client, though possible, and is interesting to kind of look at as we learn NetConf, it is not the most efficient way to work with NetConf. Other clients exist to support this, and what we're going to look at is how do we do NetConf efficiently using NC client inside of a Python script. And there are other examples for different languages and tool sets that are out there. Now above the transport layer, we get into the messages of the RPC layer. Now RPCs are not new to programming and development in this area. They've been around for years. We don't need to know all the details for it, but I think this is a good example of what we need to keep in mind as we work with NetConf. Now inside of a communication path, NetConf is a client-server protocol, and our clients, us as the network engineers using different utilities with NetConf, well, we're using a NetConf manager. And we're going to communicate with a server, which will be called the NetConf agent. And what we send is an RPC, a remote procedure call. It's given a specific message ID, and inside of that RPC, we will ask our device to do something. Once that device does it, it will send us back an RPC reply with the exact same message ID to link our RPC to the reply back to it with our requested data or with a status about our operation that went through. So RPCs are nothing more than just a way for us to request our network devices and infrastructure to do something and then match it back up with a reply that comes through. Each RPC in a NetConf communication will have an operation tag to it. And NetConf supports several operations across all of the different types of configuration and operational actions we might want to do. We've got get and get config, where get gives us the ability to retrieve both running configuration as well as state information, operational data. If all we're interested in is just the configuration information, we can use get config instead. To update our configuration, we've got edit config, where we can either load an entirely new configuration or just elements of a configuration back to our device. Copy config gives us the ability to copy a configuration from one data store to another. Maybe we've got a remote data store with a new configuration. We want to copy and overwrite an existing one. Sometimes we do need to delete elements of a configuration, so we get that capability as well. Now, when we initiate a new session to NetConf, we have the options to lock and unlock that session to avoid other people from making changes to the configuration that may conflict with what we're working on. We also have the ability to commit those through. And we do have to be able to close our sessions as we're done. When we initiate a new NetConf connection to our device, it will remain open and allow us to send multiple RPCs with different operations back and forth. And when we're done, we want to make sure we close that successfully. Should a session be maintained open, we do have an option to kill session to kill another session in the background that's been left open. Now, a network device inside of a NetConf gives us the ability to support multiple data stores. Now, a data store with NetConf is simply an entire or partial configuration element that we want to go through. We can use different data stores to stage elements of a configuration that we would later copy over to running or an operating configuration that's there. Now, every NetConf, any device that supports NetConf at a minimum must support the running configuration that's out there, and then other devices may support startup candidate or a URL-style data store for remote configuration information. Now, when we get started with NetConf and we want to use it as a transport protocol or a network configuration protocol, there's a flow of steps that we're going to use. The first step we have is we'll connect to our device and say hello. Now again, we could do that with raw SSH, but in a moment we'll see how we can do that using NC Client and Python in a much more efficient way. Once we've connected, we'll retrieve the capabilities back. And that capability list will tell us what data models and features our NetConf agent supports, so we can investigate those list of models and determine which ones we want to use. We'll then compose our operation, be that a get config, or an edit, and then send that as an RPC message off to our agent. Once the agent has processed our request, it will send us back an RPC reply that we can then inspect the data for to see what was out there. At a high level, those are the back and forth steps. Now let's dive into some Python code and see how we can actually use that. To do that, we are going to leverage the NC Client library that's available for Python. Now, the NC Client gives us a full NetConf manager implementation, and you can read the full documentation up on Read the Docs, ncclient.readthedocs.io. But what it does for us is it simplifies all the connection and communication back and forth between us as the manager to different agents that are out there. Now, NC Client will give us back raw XML that we can then process using our Python skill set that we've talked about in previous lessons. Let's dive in and take a look at a bit of code that's here. So the first one that we're going to dive into here is this example. In example 1, we're going to say hello to our device and make a connection and retrieve back all of the capabilities lists that are there. Now, inside of that with statement, it gives us the ability to make the connection. Let's dive into this code and see how it works. All right, like any Python script, the first thing we need to do is we need to import the information necessary for our use case. And in this case, I'm importing 2 bits of details. That first line, from device info import iosxe, is just storing where I've stored all of the username, password, IP address information for the device that we're going to connect to. And we leverage that later down here where we can see we're referencing the iosxe dictionary that has address, port, username, and password that are there. Now, what's interesting on this one for us is where we're importing manager from NC Client. If we remember back in the client-server perspective of NetConf, the manager is the client that we're connecting to, and the server is called the agent that's out there. With these bits in place, once we have them available, I can now use the manager object to connect to my client connect to the agent that's out there. Now, manager.connect requires to know which host, the port, the username, and password that are all available. And then we also, because we're built on top of SSH, we do have this host key verify equals false to support connecting to a device that may not have a fully, that is supporting a self-signed certificate. Now, back in the Python modules, we did talk about this with object that's here. And so this is where we can see it's actually taking advantage of outside of just file access. What the with block does for us here is it opens up the connection and stores that as this variable called m that I can then use to interact with my open connection to my router over NetConf or my device over NetConf. And then once I'm done, the with handler here will just automatically do the close session for me, so I don't have to do that on my own. With my connection to my router open, what I want to do in this example is actually take a look at the different capabilities that are available. So down here with the green arrow, we can see that we're actually looping over m.server capabilities and printing out each capability that's in the list. This gives us the ability to actually look at all of the different data models that are available that are in there. Let's take a look at what this example looks like in real life. So if I run this example, so Python example1.py, as we expected by looking at the code, it prints out all of the capabilities. Now up here on the slide, I have pulled it down because there are a lot of capabilities supported by the iOS XE device that we connected to, so I edited it down for a bit of simplicity on the slide. When you run this on your own, you will see far more capabilities printed out. Now what we want to notice here in the capabilities list is there are two general types of capabilities. Boxed off in blue are what we're going to call base NetConf capabilities, right? What features, what version of the NetConf standard and protocol is supported by this device? And we can see that both 1.0 and 1.1, which are the two types of versions that you'll typically see that are out there. Now highlighted in red are the data models supported, right? The whole point of NetConf is that we're going to interact and we're going to manipulate using different Yang data models. And so the capabilities list will indicate all of those that are in the list. Let's dive a little deeper into and look at those different data models that are there. So I've taken two of the data models that were supported and broken them up here so we can look at them. So if we break down the actual capabilities list, what we see at the beginning in blue is the model URI, or the unique name for the data model as far as the device is concerned. Now what's interesting here is that is a format that sometimes may look like a web URL, as we can see in the second example there of http://cisco.com/ns/ietfip/devs. Now, even though it may sometimes look like a URL that you could browse to on a web page, it's not. It's simply a unique name for the capability that's out there so that it can be unique inside the example. Now, following the model URI, that unique name, there will be a question mark. And then after that, we get a bunch of metadata and information about this data model that we can use as developers. So in yellow, we can see the module name and the revision date. So this is the name that we would actually work with and talk about for this model. So in this case, it's the IETF interfaces data model, and it was the revision that was kind of standardized in 2014 on May 8th. Now in green also, that what we see inside of our capability is the list of protocol features that are supported. And so this data model supports pre-provisioning, MIB access, and then arbitrary names that go through. And then lastly, what we can see is the deviations indication. What a deviation for a data model is an indication that there are, even though this standard model or this data model is supported, there are some specific changes or updates or modifications to the standard data model that this device specifically supports. Knowing that that's there, we can then go and look and find the IETF IP devs data model and look at that and combine that together with the standard data model to see what's to fully expect coming out. In this case, what we would see is the IETF interfaces data model lacks IP address information. We are able to get the IP address information using these other bits of data. Now that we've looked at the data models, we've said hello in Python, let's look at actually using NetConf to automate our network configurations that are out there. So the first bit of information we want to do is we want to retrieve interface details about our NetConf connection that are out there. So here in example 2, we're going to retrieve, we're going to get information from our device that's out there. Let's look at this code and how it goes together. So here in this code, once again, we are going to go ahead and import in all of the, we're going to import in the details that are here. So we need access to the device info, so we get the credentials and IP information for this device, as well as NC Clients Manager. Because we're dealing with XML data, right, we're going to import in our happy little XML to dict Python library that we've looked at a couple of times already, so that it makes it easy for us to work with that XML data that's out there. Once that's in place, we're going to read in a particular filter. Now what we have to do when we work with NetConf, we want to have the ability to filter down specific data models that we're after. So we've stored that NetConf filter out here in an XML file that we can look at in just a moment. Once we're inside of the place, we've got our code that's going through. We open up our connection with manager.connect here, and with that available, we are able to go ahead and send our GET request, right? So we're getting information. We're going to get all of the information from our device based on that NetConf filter. Now once that's in place and we retrieve back our XML data, we need to process and leverage all that XML inside of Python. And so we're going to use our XML to dict.parse function to turn that XML string into a dictionary object that we can work with. And then with that available, we can dive into the retrieved information and get down directly into the interface information that was returned back for us. Now in this case, what we made a request for both, we made a request for the operational details. So we're going to print out all of the current state of the interface that's out there. So we print out the name information, its description, so we know which interface we're talking about. And then we dive into details like the physical address and then the input and output packets that are supported. The value of working with the XML to dict dictionary, or the XML to dict objects here, is that we can actually treat them like dictionary objects and drive directly into the details that we're after. Now if we look at the output of this, let's take a look at what it looks like when we run it. So when we run example 2 inside of Python, it prints out all of the details about Gigabit Ethernet 1 that are out there. It shows us its name, its description, its type. Now in this case, this is something that we may just as easily be able to get using CLI information. So you may wonder, what's the value here? The value is we may want to be able to use our Python script, in this case, and using NETCONF to gather details from our devices, our interfaces, format the specific information we're after, report it back to dashboards, or provide health statistics. What's possible here is that we don't have to limit ourselves with what's capable with just the show commands on the router. Now we can get access to the raw details and construct our own reports or our own information for what's necessary and interesting for us in a particular use case. Now in our next example here, example 3, now we'll show how we can actually edit our configurations and update interface information out on the router using NC client that's there. Let's take a look at this code. So jumping in once again, right, we shouldn't be surprised. We're importing our information. We're getting our NC client manager that we can take advantage of. The next thing we want to go through is in order to do the configuration, we have to send an XML payload describing what it is that we want to configure. Now in order to do that and make it modular, what I've done here in this example is I've stored a template for our interface configuration called config template IETF interfaces XML. We're reading that template in and then we'll customize it using the details specifically for the update that we want to do. Now if we drill in and we actually look at the interface that template that's out there and how this combines together, what we can see here is we've got that XML-based data formatted in areas. And then all throughout the details inside of the template, I've put in these indications with the curly braces of places where I'm going to sub in information. So IP address where I've circled in blue, and then boxed in red is the interface name. Now down in the actual Python code, we've opened up that template file, and then we're using the .format function we've seen a few times already in the video course to replace the details. What's different here is rather than just going through and doing it by position, we can actually use the names that are there. So here I've got interface name inside of the format function is equaling Gigabit Ethernet 2, and that links back to the interface name that was inside of the template bracketed there as I've circled in blue and with the red box. Now once I've gone through and I've formatted and provided the name, the description, the IP address, the subnet mask, all of the information necessary to configure this interface, then I can move forward and have a complete version of the XML configuration payload necessary to make this change. Now coming back to the full the full element of the code that's here, at this point, this is where we left off in our description. We've created our NETCONF payload that we can leverage. In our script, we'll go ahead and print it out so we can actually see what we're fully seeing and what we want to do the configuration for. And then we can open up our new connection to our router using the manager.connect function we've seen already. Now, instead of doing a git config or a git to get operational detail, now we're using the edit config method of NC client to send an edit configuration that's there. We have to provide it a payload that describes what we want to edit, and then we have to target a data store. In this case, we're targeting the running data store. Once we've made that connection, we'll go ahead and print off the NETCONF reply that's there to see whether our request was successful or not. Let's see this script in action. So when I run this script, I go ahead and run Python example3.py, and as expected, we've constructed an XML configuration payload to describe the new configuration we want to give to Gigabit Ethernet 2. And then at the very end, we see it printed out that OK statement inside of the RPC reply. Now, when we send an edit config, we don't get back a configuration bit. We just get back an acknowledgement that the router, the agent on the router, was successfully able to do what we asked it to do. It gives us back that OK. Now, in summary, we've taken a look at the NetConf protocol. We've seen a couple of examples of how we can use it. And we first started out by asking ourselves why technologies like NetConf, RESTconf, and Yang were developed, and then how they relate together inside of an overall model-driven programmability approach. We looked at the elements of the NetConf transport protocol, SSH as a transport, RPCs for a message delivery, different operations that are supported, and then finally how we see the data back in XML. We then ended with an example of actually retrieving and configuring data using NetConf from an agent at the endpoint. Now, if you didn't follow along with me in these examples as I went through, that's fine. Go ahead and take time now, connect into the DevNet sandbox, run these examples, and see how they go through. Maybe explore yourself and see if you can change the information inside of the scripts to configure a different interface or change the IP address that's there. Now, also be sure to complete the full network programmability basics course. The next lesson in this module on network device APIs is the RESTconf lesson, where we look at how we can still use Yang data models, but now in a REST-like interface or a REST API-like interface. As always, be sure to join me up on DevNet at developer.cisco.com for access to Learning Labs, Sandbox, and so much more that we have available. Now, if you have any more questions, you can always find me. I'm available through email and Cisco Spark at hapresto@cisco.com. I'm fairly active up on Twitter at hfpreston, and you can follow different code samples and examples that I post up on GitHub at /hpreston. Also, make sure you follow Cisco DevNet so that you can get updates from our entire developer evangelist team and engineering team on all of the great things that Cisco has to offer for developers. Thanks so much for joining me in this lesson and this discussion on the NetConf protocol. Be sure to stick around for the next one where we dive into RESTconf, and we can see how we can use REST APIs for network configuration as well. Thanks.